My name is Jeannie Morris, and this is my exercise 5 on clustering and segmentation. So first we will be looking at hierarchical algorithms for extreme clustering. I was asked to watch a video and then answer the following questions. What are the shortcomings of the hierarchical clustering? So when doing this, there cannot be any missing values in the data, or it most likely will not work. It's not suitable for large data sets. It's often difficult to calculate the similarity between clusters. It often does not provide the best results, and it does not allow you to pick the number of clusters you want. It simply just tells you what two things are most similar. And then it asks what the main ideas underlying how PERCH clusters data. PERCH stands for Purity Enhancing Rotations for Cluster Hierarchies, and it is designed to scale to a large number of points and to scale to a large number of clusters. The algorithmic ideas of PERCH are that it consumes data points one at a time and then incrementally builds the hierarchical clustering. And when a data point arrives, PERCH then routes the point to the node containing its nearest neighbor, and the point is then stored in a newly created leaf that is a sibling of the nearest neighbor node. I was then asked to watch a video about k-means clustering and to answer two more questions. What are the algorithmic main ideas behind k-means clustering? So first, you're going to decide how many clusters you would like to identify within your data set, and this number is referred to as the k in k-means clustering. Then you will select 3 distinct data points at random, and this number can be any number. 3 is the number that was used in the video. During this step, you will measure the distance between point 1 and the other initial clusters, and the number of initial clusters is determined in step 1, when you're deciding how many clusters you would like to identify. Then you will assign the first point to the cluster it is closest to, and you will then proceed to do this for the rest of the points within your dataset. And then at the end, you will calculate the mean for each of these clusters. I was then asked about the shortcomings of k-means clustering. So from what I could see, you're unable to see what the best clustering would be. So as a means of creating the best clusters for your data set, the process must be completed over and over again using the total variance. And you do this with different starting points, and I found that this could be very time consuming depending on the number of data points and clusters you have, which is a shortcoming. And then also it is sometimes difficult to determine what value to set for k. And then we were asked to go into SAS Viya and do an activity called Moneyball using the NBA 2018 dataset. So here we are in SAS Viya, and I've went ahead and clustered this to save some time. So this is the initial NBA 2018 clustering, and I used points, rebounds, assists, steals, blocks, and turnovers in this. And here we have 5 cluster groups. And if you click on each one, you get a better idea of how each one is clustered and gives you a good breakdown, and you can click on each of these different ones. And you're also able to maximize it and get some more details here at the bottom. Trying to see if I can get to it for y'all. Yeah, here you can see the cluster ID and how the points, rebounds, assists, blocks, how everything's broken down. Here we have 7 cluster groups. As you can see, it's a bit more crowded and more difficult to understand what's going on. And then we have 9 cluster groups, which again is much more difficult to see what's going on as there's more cluster groups and everything's more crowded together. When we expand this, again, it's just very crowded and hard to understand. So then in this diagram, we have 5 clusters and 10 bins, which is the same as what we have here. So let's go to the 5 clusters and 16 bins. And again, this is just very crowded and hard to understand what's going on. And then here we have 5 clusters and 4 bins, which I feel this is much more easily understood. It's more spread out and you can see what's going on a bit better. We see that cluster ID 5 swoops down and steadies out at the bottom. And you can click on these tabs over here if you just want to view certain cluster IDs. So going with the 5 clusters and 4 bins, since I think this is the best option, we're going to look at a 2 cluster visualization. So we have 2 cluster diagrams side by side, and I broke them up so not all the information is in both of these. Now it's broken up into 2. So in this one, we have the turnovers, assists, and blocks. And then in this one, we have points, rebounds, and steals. So we can see here that points is 30.4, which is very high. And rebounds are 16. And then over here in the first one, the numbers are much lower outside of assists. I feel that we can conclude that the higher this number is, the more disorganized it does look as the data is heavier. Let's zoom in on these to get some more information. So we can see that cluster ID 4 is very large along with cluster ID 3. Now if we're going to look at one of these, despite using different data, this has the same thing, only cluster ID 2 looks a bit bigger. And this concludes my presentation. I hope you enjoyed.